dy by dx problems. I love these, just because I think they're a really nice extension to differentiation and everything that we've done so far. So this is the sort of issue where we have a function that says x equals something in terms of y. And it would be an absolute nightmare to rearrange it so that it says y equals something in terms of x. So instead we just ignore all of that, don't want to rearrange, and instead what we'll do is we'll find dx by dy instead, and then reciprocate. So we'll just say, okay then, well then flip everything over, and that gives us dy by dx, and so that must be 1 over whatever the function is that I'm left with. The only problem is, and I've kind of deliberately, but also by mistake, these are y's. That's an issue for us. Because now I'm saying a function y in terms of x is something to do with y, which isn't true. So quite often then what we have to do is then do a rearrange and subs of some function. And actually, a lot of people find this quite annoying. I find this really enjoyable. It's probably why I love these problems so much. I think they're great. But that rearrange and substitution so that you get the function in terms of x is what makes this really satisfying. So here is a problem that we can do. So we've got the function x equals 1 over y plus 1. I could rearrange this one actually, that wouldn't be too much of an issue, but let's for the sake of this problem go for differentiating with respect to y. So I'm going to end up with dx over dy in the end. I could do this using the quotient rule, I could use the product rule, I think, or, well, I couldn't use the product rule actually, but I could use the chain rule. I will do that. So that is x equaling y plus 1 to the power of minus 1. I think that's quite nice. And so, if I, well, let's do this properly. So this is t to the power of minus 1, where t is y plus 1. Now, dx by dt is minus t to the power of minus 2, and dt by dy is 1. Putting those together using the chain rule, dx over dy is these two functions multiplied together, so minus t, which is y plus 1 to the minus 2. Okay, what am I going to do with this at this stage? So there's my chain rule, and there's my answer. Well, I've got supposedly a function x in terms of y, that's absolutely fine, but now what happens when I want to know what dy by dx is? Well, I need to just reciprocate the other side. So currently here I have minus 1 over y plus 1 squared, just by moving, sort of evaluating part of that index. So reciprocating that will give me minus y plus 1 all squared. So now function y in terms of x differentiated is something to do with y, and that's an issue for us. So I need to find an expression for that y right there. Well, I know that x is 1 over y plus 1. So y plus 1, if I multiply it up, times by x equals 1. So y plus 1 is 1 over x. Now I can replace the y plus 1 that I've got in my equation with 1 over x, leaving me with dy by dx equaling minus 1 over x squared, or minus 1 over x squared. So as you can see, it's quite a nice little trick. It just allows us to reciprocate. One of its really nice applications is that we can now do another proof for the derivative of ln x being 1 over x that doesn't require first principles, because we can just use this dx by dy thing. So I'm going to let y equal ln x. So I'm looking for dy by dx now. If I let y equals ln x and I try and differentiate now, I would have to use the rule that I know. And I don't want to do that, I want to prove the rule that I know. So I'm going to have to go about this a different way. I'm instead going to remove this ln from x, which means I need to apply e to both sides. So e to the y equals x. Now I'm going to differentiate that instead. So I'm going to differentiate dx with respect to y, because my function's now in x, and we know that e to the power of something differentiates to e to the power of something unless that something is a function in itself. Y is just y, so that's absolutely fine. We'll just make that e to the y. That means that dy by dx is 1 over e to the y, because I'm just reciprocating, flip it upside down, flip it upside down. And I know that e to the y is x, because I set that earlier. That was part of the consequences of letting y equal an x. And so dy by dx in terms of x, which is always what I want to do, is 1 over e to the y, and e to the y is x. It's 1 over x as required. So it's just a really nice little trick. I've included some questions in your pack. They're worth having a go at. It's just a really nice way of practicing your differentiation. So enjoy it.